What's up? What's up? What's up? It's your boy, the network. And today's topic is section 3.4, configure and verify default routing. This is a topic in the CCNP route exam code 300-101 version 2.0. Let's take a look at the exam blueprint to see where we came from and where we're headed. All right, this is the exam blueprint implementing Cisco IP routing. Again, this is exam code 300-101. Make sure you are studying for the correct version. That's version 2.0. Sometimes there'll be some older material out there that you might be, looking into, but realizing, I believe it's I say about 80 to 90% from the old exam, is in this new exam. But there's some little parts that could, if you ain't studying for that stuff, it could mean the difference between failure and passing, failing and passing. So, or life or death, whatever you situation you in. Anyway, we just wrapped up section 3.3, configure and verify static routing. Today we're going to be doing 3.4, configure and verify default routing. After that, we're going to do section 3.5, evaluate routing protocol types. Notice there's 3 types of routing protocols, right? And notice that there's only one section for configure and verify default routing. However, this was, as I was reading through the material, I realized I don't think I can get all of this in one video. I know my goal was to, keep these videos under 30 minutes. And if you've been paying attention to these videos, obviously they've been lasting for well over 40, 45 minutes. And it's just the breadth of material. There's just so much material that I really can't just, put them into some nuggets, if you will. But I'm going to try to. So that's why for this video, we're going to have to break it into 3 parts. Actually, might be 4 parts. I will see. We'll see. But however, it's going to have to get split. And I could not do all this in one video. And I wasn't finna do no 3-hour video because nobody ain't going to really sit through that. So let's go ahead and start off. Again, configure and verify default routing. Default routing, let's start off with defining that. Default routing is, I think we kind of went over that in last video. Actually, last video we talked about static routing, right? So a static route, remember, static means it's always the same as opposed to dynamic, which means it's always changing. A static route is one route that you got that's set to just how to get somewhere, right? So like, how to get to the McDonald's right around the corner. You take route A to B to D, whatever, left and right, and it'll take you there. That's the static route to get there. It might be some other ways to get there, but you got one static route that'll take you there. Now, that's what a static route is. Dynamic routes, we talked about that. It's always changing. It's like there's different routing protocols like EIGRP, BGP, OSPF. Those are different dynamic routing protocols that give you different ways of how to get somewhere. And that's done automatically when the link is down, give you updates, etc., etc. Now, let's talk about default routing. Default routing is a type of static route. The difference is, I came up with this on the fly in the last video, actually. If you paid attention, it's somewhere in the middle. I came up with it on the fly. Remember, we talked about with networks, we can always compare them with roads on a highway. I just did it about 20 seconds ago. Roads on a highway, right? Or roads in the neighborhood, roads in the city, whatever. Now, when we talk about default routes, let's say you're trying to get somewhere like, I don't know, Vegas. If you live in Vegas, make pretend you're not in Vegas. Make pretend you're in another city, Seattle, whatever, right? You're trying to get to Vegas and you stay in New York City, right? You get in your car, right? And you don't know how to get to Vegas, but you know how to get out of your neighborhood, right? So it's probably like 2 or 3 ways to get out of your neighborhood, but it's one way that's for sure going to take you to some other main roads. That's going to take you some other main roads to the highway to get to wherever, right? You don't have no way. You don't know how to get there. Like you say you ain't got no GPS, whatever. You don't know on your mind exactly how to get to Vegas, but you know how to get out of your neighborhood. That one road that that's going to take you out to the main road that's going to take you out of your neighborhood will be considered your default route, if that makes any sense, right? So, and I'm going to show you how to configure that on the router. We're going to do it in, yes, my favorite packet tracer. When I know, like I said, this is a CCNA tool, but it's easy for me to explain. You might not take me seriously because I'm using Packet Tracer for the CCNP exam, but whatever. Like I said, we're going to break this section, 3.4, configure and verify default routing, into different parts. And somewhere along the way, pardon the pun, we gonna use GNS3, or maybe, no, I don't think we're gonna use Boston in this one. But I'm gonna try to create a topology so that way we can explain it. Because like I said, this section here, it was more than I could chew. So remember, this is not a training course. This is my learning journey as I was taking the CCNP route exam. Let's head over and take a look at the official definition. This right here. Again, this is kind of like what I did with the last video, static routing versus default or dynamic routing. This is not what you would consider. This is just imagery that I created that reminds you of what default route may look like, but it's not necessarily a default route. It's just some more corny imagery that I came up with again. So I came up with two definitions for y'all. One from Cisco, one from Wikipedia. We all know Wikipedia. Anybody can edit it. You can see vandalism on there. But I, however, like definitions from Wikipedia. We got two. We got the official one from Cisco. Default routes are used to direct packets addressed to networks not explicitly listed in the routing table. So let's say you got the routing table, which is kind of like your map. You look on there, you ain't got no real ways to get there. But at the bottom of the map, they say, hey, if you want to get out of this neighborhood, take this road, basically, right? And that's what you would see you would even see that on a routing table. You do show IP route. At the bottom, you'll see us say gateway of last resort. And it'll tell you which interface or which IP address interface you got to take to pretty much get out of your neighborhood or get out of your network, basically, or leave that router. Not necessarily network, but yeah, it's basically network. I'll show you an example of that. Default routes are invaluable in topologies where learning all the more specific networks are not desirable, as in case of stub networks. Stub networks, we talk about that, right? It's only one way to get in that location, one way to get out. So it's good to have just a static route as opposed to a dynamic route, because if you put a dynamic route for just one little neighborhood, one way to get in there, why would you need to do all that? Because if you use like a routing protocol like OSPF is a routing protocol that uses processing power from the CPU to calculate different routes using an algorithm called SPF, or what is it? Yeah, I believe it's the SPF algorithm. I can't remember. I'll double check and put it in the notes below. But basically, it uses your CPU, and the more calculations it got to make, the more changes it make, it's going to use more processing power. Yes, for one route, it'll just be one route, but it'll still use processing power to calculate that route. So why would you do that when you could just put a static route? You get that if you do that. But anyways, it would just be a waste of resources. It's not desirable as in case of stub networks, or not feasible due to limited system resources, just like I said, such as memory or processing power, just like I said. Take my word for it. And this is another definition below. It's a little bit more detailed. Go ahead and pause it if you want to, or I may put it in the notes below so you can copy and paste it. But like I said, I like the Wikipedia definitions. That's why I grabbed it. So from now on, I'm gonna start taking Cisco and Wikipedia, because like I said, we studying for Cisco exams, so we really should be taking terminology from Cisco website or the Cisco manuals or white papers, whatever. But I like Wikipedia definitions because they're really broad and they're really specific. And I don't know, it's just something. This is something when I read, they just make more sense to me. So, all right, so we got 3 different ways that we can configure our default route. Right? We talked about the last one right there, IP route. That's basically a static route. However, if you remember in the last video with static routes, we are putting specific IP addresses. So we saying to get to Vegas, take this road. Right? But as in point of a default, when we talk about a default route, we just saying to get out of your neighborhood, take this road. Notice how I didn't give you a specific city. I just gave you to get out of your neighborhood, take this road. That's basically, a way for how I remember it. That's a way to kind of explain it. So we got these other commands that we could do to configure our what's called gateway of last resort, right? Using IP commands. Again, the gateway of last resort is our default route. However, a default route is a type of static route. That's why some of these commands might look redundant it might look redundant from the last video. It might sound redundant because of the last video. IP route, we discussed that in the last video. So we're going to discuss each one of these. Then I'm going to give you an example in Packet Tracer. Okay, so we got IP default gateway. That's one command we type in to configure a default gateway, or a default route, what's called. Now, you want to use this command. As you can see, it says this command differs from the other two commands, which are these guys right here, default network and IP route 0, or sometimes this last one called the quad 0 route, or your 0 route, right? IP default gateway command differs from the other two commands. It should be only used when IP routing is disabled on the Cisco router. You might be asking yourself, when the hell would a routing be disabled on a router? Well, IP routing may be disabled on not necessarily a router. It could be, but 9 times out of 10, it would be disabled on a layer 3 switch. That's not, now remember, layer 3 switch can route, right? However, it's not enabled by default. You got to type in, I believe it's IP routing to turn on routing on a layer 3 switch, right? Now, if it's off and you need to just keep it off, you don't want to use this layer 3 switch as a router or do any routing on it, or even a layer 2 switch, and you need to configure a default gateway, you would type in this command, IP default gateway, and then the address you want to point it to get out of your neighborhood, essentially, right? And this is an example right here below. IP default gateway. This example defines the router on IP address 172.16.15.4 as the default route. So that is the default route. So you can do that on a router that has IP routing not enabled. I think I did something like that in the ICNP redirects video. We did that in the ICNP redirects video. We used one host turn round. We just wanted that router to just be a host. So we didn't have it do any routing. I turned off routing on it. However, I configured a default gateway by using this command. I believe I did that in that video too. You'll see it in, if you really want to go back and reference it, it's in, 1.3a, ICMP unreachable and redirects. We did that in. So that basically, if you have a router or a layer 2 switch, or even a layer 3 switch that does not have IP routing enabled on it, you can use this command to have it point to a default gateway. Or if you are in, if you're low end, it says here, it's snapping on your router, on your like as if you can't afford it. You might also use this command when your low end Cisco router is in boot mode in order to TFTP a Cisco iOS software image to the router. In boot mode, the router does not have IP routing enabled. So you know what ROMMON mode is, right? If y'all know what that is, I'll leave a comment below, or I'll leave it in the notes below. ROMMON mode is basically when you don't have like iOS or on enabled or installed on your router, or it crashed or whatever, it's not booting up. You'll go into ROMMON mode. That's kind of like a maintenance. You know, it's kind of like the BIOS on your router, right? And it's basically short for ROM, right? Read only memory monitor mode. So ROMMON mode, they just call it that. And you use that to if you need to fix the router, it's like I said, it's basically like firmware on the router. And if you don't have routing enabled, you're not going to have routing enabled on it because it's in ROMMON mode. It's basically something wrong with it. So they put you in that mode. And if you need to do some kind of routing, you can type in this command, IP default gateway, blah, 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 and that'll at least give it a gateway to to point to if it needs to. Like you might have a TFT, you might have it point to a server, TFTP server, or you might have it point to a router that knows a route to the TFTP server to grab whatever you need. And this is default network. So unlike the IP default gateway command, you can use IP default network when IP routing is enabled, right? When you configure Now, yeah, so when the IP routing is enabled, when it's on, right? When you configure IP default gateway, the router considers routes to that network for installation as the gateway of last resort on the router, right? You might ask yourself, well, won't you just type in IP quad 0 to get to wherever? Well, with this, for every network configured with the IP default network, if a router has a route to that network, that route is flagged as a candidate default, which means like, okay, we could use, like, we don't know how to get out of this neighborhood, but you know, we could use this route to get out of this neighborhood. This network diagram below displays the routing table taken from 2513. I'm gonna show y'all on the next slide. I'm just kind of like reading this to y'all. But anyway, let's look at this topology right here. We got router 2513, right? And you got two networks, right, to get to this network and to get to that network, right? The 24.1 and the 10.1.1. He got two ways to get to, he got one way to get there and one way to get there, right? Now, if we do IP, now, let's say you got your network over here, right? Come out. How do we know which way to go to get to the internet, right? This way or that way? Well, when you type in IP default network, you can make it seem like this is how to get, you could just explicitly say this network is how we get to the internet. And you would do that by typing IP default network and then that network. I believe it's either that network or the interface to this network. I believe you would have to do the interface to that network or that network. I'll show you in the next slide. So right here, we configured 10.1, which would mean, okay, so then, yeah, it was this network right here. So let's say we wanted to get out of this network, and we said to get to the network, to the internet, we'd have to take this network, not necessarily interface, but network. So we type in IP default network 10.1.0. So we saying 198.10.1.0 is how we get to the internet, right? So it's not necessarily the next hop address. We just saying this network is our default gateway, kind of. So we, instead of the interface being our like, and when we did the static routes in the last video, we said the static route was our the static route to a specific interface was our default like how to get out of the neighborhood. Now we're saying instead of an interface or forwarding router, we're saying a specific network, not an interface, but not a specific router, forwarding routers next hop. We're saying a network is how we get to the internet. Take this network to get out of the internet. That's what we're saying with IP default network. That's the difference, right? So remember, this is our default gateway. We're using a specific IP address, right? And then with IP route, we'll go over that last. That's the quad 0 route, right? And then this right here is the default network. We're using the network to get out to the internet. And as you can see, it shows up at the bottom. And then that's right here what I said about looking in the map. It says, we don't have a way to get there. But if you want to get out of this neighborhood, that's what this is saying. Like, we got these routes to get out of here, to get to there. We got to get to there. But if you want to, if none of these neighborhoods are somewhere you need to get to, and you need to get it, just basically get out of this neighborhood, use this gateway of last resort. So it's 161.44.192.2, right? So it is an interface, but it's saying to this network, to get to that network, use this interface. But when we typed it, we said IP default network. Notice we didn't put a specific interface when we typed it in. We just put in a network. And essentially, it essentially became our static route. Because remember, a default route is a type of static route. That's why it came up here. You don't see no D's in here talking about no default route, right? It's a static route. So that's why we got an S here. This star means candidate default. It means it could be used as our default route, right? And then this network, here's the AD, remember? Administrative distance. Static routes is always 1. We said that about 10 times in the last video. Remember, you go back. I found myself sounding like a broken record. And then 0 for the metric. Static routes, the metric's always 0 via this interface. That interface right there. 192.2, 44.192.2. And to get to that network, we take this next hop. Again, this is the IP route we use. This is basically stuff we talked about in the last video. IP route quad 0. This is basically a this is a default route, really. This is a default route. So quad 0, say this is the internal network. There's us. To get to the internet, we basically saying quad 0. So to get to this network, not necessarily this network, but to get out of here, really. When you see all zeros right here, this is basically like I said, this is like we need to get out of here, basically. Take this next hop, 172.16.3.2. To get to the internet, take this next hop right here. Or we could do IP route, right, to get to the internet, or out of this internet, out of our network. Take serial 00, which is our interface, our local interface, right? So to get out of here, take this back door or this front door, whatever you want to call it. That's it's in our house basically, or our neighborhood. It's like if we get in our neighborhood, right? Like my complex, we got a security guard at the gate, right? The security guard at the gate would be serial 000, if that make any sense, to get out of here. Again, IP default route used in ROMMON mode, like I mentioned before. Here's another default route example. I'm not going to explain this one. Y'all can freeze frame it. It's basically saying the same stuff I've been saying. And we got static routes and recursive lookups. Recursive lookups are something that I'll show y'all an example of this in the next video. I mean, not next video, but in the next activity. When you use a next hop address with a static route, when you use a next hop address, right, with a static route, which is basically what we did in the last slide, the router will have to look at the table twice. Why? You might ask. The first time is to find the route. Right? It got to look up in this routing table. See, do I have it? Do I have it? And the second time will be to resolve the route to the next hop address. So it's got to look it up twice. That's why it's called a recursive lookup. It is recommended to use an interface instead of a next hop address on point-to-point links, right? So when you got a point-to-point link and it's like a /252, that's normally a point-to-point subnet mask. You want to use the interface instead, right? Otherwise, it's going to have to look up the address twice. On a broadcast network, if the next hop address is always out the same interface, you should use both the exit and the next hop address. So the exit interface, which will be a security guard, 000, and the next hop address, which will basically like the name of the road to get to that gate in my complex, out of my complex. Avoid using just the next hop address, and we'll save the router from doing recursive lookups. All right, so let me show y'all an example in Packet Tracer. All right, we're going to configure IPv4, static, and default routes. So this is basically a combination of points made in the last video and points made in this video as well. Again, with static routes, or default routes rather, we're going to break this stuff up in 2 videos, 3 or 4 videos. So this, we just going to be talking about just plain old default routes with IPv4. And that's it. We're going to break down some other stuff, doing default routes with EIGRP and OSPF and a whole bunch of stuff in the next video. So check this out. Let's take a look at this topology. Zoom in for y'all real quick. All right, so we got the 31.0 network, 31.1.0 network, and the 31.1.128/26. Notice these are variable variable length subnet masks. We got different subnet masks, so it gets a little tricky here. In this activity, we're going to configure static and default route. Static route is a route that is entered manually. We talked about that by the network admin to create a reliable and safe route. There are 4 different static routes that are used in this activity. Recursive static, directly attached, fully specified, which we talked about in the last video, and a default route. Default route is basically how to get out the neighborhood. Okay, looking at the topology diagram, how many networks are there in total? We talked about that, right? This is 1, 2. Actually, there's essentially, okay, so look, 1, 2 networks, 3 networks. Don't forget these guys right here. 4, 5. So it's actually 5 networks. How many networks are directly attached or directly connected to router 1, 2, and 3. So router 1 has this network directly connected and this network directly connected. Right? Router 2 has this network connected to him. That's router 2 right here, right? He got 1, 2 networks, 3 networks connected to him. Router 3 has 1 network over here and 2 networks over here. So basically he got 2, he got 3, and he got 2. You can kind of just look at the lines connected to them. That basically tell you how many networks are connected to them. If this was layer 3 and then they broadcasted a different network, then you could just, either way, it'll just be 2 networks. So these are local area networks, which is, they don't really break broadcast domains up. How many static routes are required by each router to reach networks that are not directly connected, right? How many static routes are required by each router to reach networks that are not directly connected? So router 1 has this network not directly connected to him and this network not directly connected to him. So he got 2. Router 2 got this network and that work that he's not directly connected to. So he got 2. Router 3 got this network. Look, this is router 3, right? He's not directly connected to that network or this network. So he got 2. Let's test connectivity from 2 to router 2 and router 3 lands by pinging PC 2 and 3 from PC 1. So let's go ahead and go to PC 1 and let's go ahead and ping let's ping PC 3. We know it's not going to work because they wouldn't have set it up for us to 172.31.1.190. Destination host not reachable. Unreachable. He got an unreachable from 31.1.1. Who's that? That's most likely his default gateway, which is somewhere in here, right? Router 1 probably. 31.1. Yep, that's his default gateway. So he got an unreachable. I'm not going to do the other ones because we know they ain't gonna reach. Why were we unsuccessful? Why? We ain't got no routes to get there, really. We really ain't got no routes to get there. We could have made a default route, but they ain't got no default routes. Otherwise, this probably would have worked. We probably should do a show. Let's do a show IP route just for the sake of it. It's a 19 something router. What is this? 2900. I was actually thinking about getting one of these. Yo, I got me a good ass deal on. I know you probably wondering why would I get physical routers, but man. 6, I'm not going to tell you where I got it from, but 6 2800 series routers. The big fat ones, right? They kind of old. They got version 12 on them, but I'm going to upgrade them to version 15. $50. So keep, looking in Craigslist. There's a whole bunch of like apps that you could find, used equipment. So there's no excuse. We could virtualize all this stuff. GNS3 is free. There's no excuse not to be able to learn this stuff. We're going to go to not configure terminal. We're going to do show IP route. Take a look what we got, what we're working with. We got a route to the 31.1 network, which is directly connected to us, right? The L's are essentially our interfaces. So don't worry about those. That's the interfaces that we have. They're directly connected. Right. The other network we're connected to is 31.1.192, right? Which would be this guy. That's who he's connected to. Those 2 networks that he know about. It says here, let's configure a static route, recursive static route on router 1. What is recursive static route? Why does a recursive static route require 2 routing table lookups? We talked about that. Static routes and recursive lookups. When you use a next hop route address, with the static route, the router will have to look at the routing table twice. Why? First time is to find the route, and the second time will be to resolve the route to the next hop address. Go ahead and pause this if you want to and look at it. That's the answer. Configure a recursive static route to every network not directly connected to router 1, including the WAN link between 2 and 3, router 2 and 3, right? Right. So this guy right here. So we need a static route to get to here, a static route to get to here, and also the static route to get to this network in between 2 and 3. Let's start off with the static route to get to this network right here. Configure terminal. Y'all remember how to do a static route? IP route. And then we're going to say to get to that, not a default route now, a static route. We're going to say to get to 172.31.0.0 subnet mask 255.255.255.0, take the next hop address of, which probably will be router 2's serial interface. Let's see what that is. Do show CDP neighbors. It's probably not. Oh yeah, it is. Good. Oh, we only got a switch connected, so we don't know what router 2. Let's just use the lookup table right now. Let's just use looking table, address table rather. Router 2 serial. It's probably this one right here. Yeah, it's most likely that one. So use that next hop address, right? IP route slash IP route 31.0. Use next hop address of router 2, which would be, so to get to this network, use this next hop right there, this little green dot right here, which would be that address. How do I know that? Well, they're labeled, as you can see right there. 172, it just makes it super easy to explain to y'all. 31.1.193, right? Now let's take a look at our routing table. Do show IP route. Now we got the route to get there, right? Right here. We didn't have that before. You don't believe me? Rewind it a couple seconds, a couple minutes, and you'll see the routing table. Actually, here. It didn't have it before, right? That static route. We didn't have a route to the 31.1.0 network. It was variably subnet. It was variably subnetted, but we didn't have one. This is /16, right? We didn't have one to that /24 specific network. Now we do, which is that right there. 31.0.0. AD is 1, administrative distance, right? That means the trustworthiness of a route. 0 is the metric, because AD static routes, the metric is always 0 via this interface or that IP address, which is that guy right there. Now we need a route to get to this network over here. Same thing. Make this a little smaller for y'all. All right, so IP route to get to the 172. What network is that? 31.1.128. 31.1.128. The subnet mask is /26, so that would be 255.255. That's 16, right? 255, that's 24. And then we need /26, so 128, 192. Right? And then the next hop address would be the same thing. This is how we get there. That interface. To get to this network, we have to take that interface, because that's the only way we know how to get to. We don't know how to get anywhere else, but that we explicitly saying this is how we gonna do it. The next hop forwarding router's address, which would be there will be that serial 000 interface. This guy right here, 72.31.1.193. Right, now let's look at our routing table. Do show IP route. Now we know how to get there. Right here. Right? Do we have a default route yet? No, not yet. We haven't explicitly created one. Why is there not a candidate default? Why is the gateway of last resort not set yet? We are creating static routes, not default routes right now. We're going to do default routes in a second. Now we need to create a network to get over here. Right? Explicitly say how to get there. So we're going to do IP route to get to 31.1.196. So 172.31. My bad. 31.1.196 / which is /30. So that's 255.255.255.252. And then the next hop address will be the same thing as the other guy. This one right here. 31.1.193. paste, bam, do show IP routes. Now we know how to get there, right? Y'all see that? So these are still static routes. I guess I really ain't show y'all nothing new yet. Let's do a default route. I might have done the default route in the last video too, though. So it's kind of mix and match in here. Test connectivity to the router 2 LAN. So we need to test connectivity to this LAN right here. And ping the addresses of PC2 and PC3 from router 1, I believe it is, right? PC2. Let's see if we can ping PC2 from PC1. They didn't say which computer we got to do it from. PC2 is ping PC2 172.31.0.254. Ain't gonna have no route to get there, I don't believe. Can router 1 do it though? He can't get there. Alright. Why were you unsuccessful? We don't have routes to get to those specific networks. I mean, we do have routes to get there, but we don't have no default routes, I believe. I don't know. I really can't answer that question right now for y'all. How does a directly attached route... Remember, this is my learning journey. Not no damn... This ain't no CCNP course, all right? How does a directly attached static route differ from a recursive static route? A directly attached static route is a route that is directly attached to us. It ain't one that's, you know, like these guys right here. This is not directly attached to us. However, if we created a static route to get to this guy, that would be directly attached to us, right? But you would think those are connected. Wouldn't they just be local routes? Yes and no. Configure a directly attached static route from router 2 to every network not directly connected. So I'm finna show y'all now. Yes, I said finna. And I'm originally from New York, believe it or not. Configure a directly attached static route from router 2 to every network not directly connected. So from router 2, who's not directly connected to him? He got this one directly connected. Just look at these little, it's like a router on a stick almost. We got a route there, and a router there. These guys are not directly attached to us. These local area networks. So we need a route to get to 31.1.0. Let's do that real quick. Enable IP. Let's see. My bad. Configure terminal IP route to get the 172.31.1.31.1.0 /25, which is 255.255.255.128, I believe. Take the next hop route of this guy. So router 1 serial interface. That guy right there. 172.31.1.194. Take that route. All right, let's take a look at his routing table. We almost done, y'all. It's almost time to wrap it up. Like I said, man, this would take much longer if we combine all of our information on static routes on these videos, because there's different ways to propagate static routes and default routes. That's why I said we're gonna have to break this up, man. I know it was just only one section with no subsections, but we really gonna have to break this up. Let's do Control Z, show IP route. Take a look at what we're working with here. Now we created a static route to get over here, right? That's over here. That's this right here. All you got to do is look at the S, right? Static 31. To get to the 31.10 network, it's the AD, it's the metric. Take this next hop. That's basically essentially what we did with that command, right? Now we need to create a static route from router 2 to get to this network. Let's do that. IP routes. I know I didn't show y'all this is supposed to be a video on default routes. I believe the last step is going to be default route. to IP routes to get to the 172.31.1.128 network. Subnet mask is 255.255.255.192. Take the next top route of 172.31.1. It's router 3 serial interface, which would be this guy. That's wrong. I meant 31.128 network. So my bad. Let's control A. Let's control A. No. Router 2. What I meant to say was that guy. Let me copy this guy again. That was this route. Copy. Paste. All right. So now we got a route to get from this network to that network from the vantage point of router 2. Right. Let's look at his routes now. Exit. Show IP route. All right. Now we got another static route, which is this guy right here. Y'all see that? That guy. Now we got one more default route to do. How does the default route differ from a regular static route, right? A default route is just basically quad zero route. You ain't got no specific network. You just put in zeros. Say, hey, to get out of this neighborhood, take this road, basically. Configure a default route on router 3 so that every network not directly. So we don't do default routes for router 3 to get to every other network not directly attached to him. Who's not directly attached? This network right here and this network right here. So we need to create default routes to get to those networks. Basically quad zero routes. That's all it is. Enable, configure, terminal, all right, IP route, quad zero. Subnet mask is also quad zero. To get to that network, take the next hop, which is router 2's other serial interface, which is the other /30, I believe, which would be this guy, 197, right? So 172.31.1.197, and basically that's his default route. Basically, what you're saying, there's only one way out of this neighborhood. So to get to anywhere else, just take that default route. So now if you want PC3 to ping PC2, for example, let's go ahead and ping 172.31.1. What's PC2? 31.0.254. And we got a reply. Alright, and I'm not going to ping the rest of these PCs because I know they work. If you like this video, please comment, like, subscribe to the network.